My name is Fred van der Merwe and I'm a design and manufacturing technical specialist at Cadpro Cadgroup. In the following video I'm going to share a quick and simple process for importing meshes into Fusion 360 and preparing those meshes for 3D printing. Start by uploading the STL file into my Fusion project. The file I'll be using is this STL, which is approximately 60 megabytes in size. As we can see, once uploaded into Fusion, it's a very detailed model. Our goal is to reduce the complexity of this file enough that I can convert it into a manipulable CAD model. I also want to scale it and make some alterations to the geometry before 3D printing it. By finding the mesh body in the browser and right-clicking on it to view its properties, we can observe detailed information about the mesh. There are two mesh-specific sections in this properties dialog that we are interested in. Firstly, the mesh analysis section. This confirms the health of the imported mesh file. Here everything is okay, as it confirms that our mesh is closed, oriented, and has positive volume. Next is the mesh expandable section, which provides facet count, vertex count, and some additional information. I'm primarily concerned with the facet count and vertex count, with one being a result of the other. This model has roughly 1.2 million facets and a vertex count of approximately half that. That's too much to work with comfortably. If I were to proceed and try to convert this into solid geometry, I'd have a horrible time and Fusion would likely freeze up. Our goal is to reduce the facet count to less than 100,000. At that point, the file becomes much more workable and can be converted into a solid model. Ideally, I like to target around 10,000 facets, modeling with conventional Fusion parametric features. Where you end up between 10,000 and 100,000 will very much be governed by finding a balance between the amount of detail that you want to preserve and the performance of the software. Simply put, fewer facets means it's easier to work with and you'll spend less time waiting, and vice versa. I'm now going to switch over to the Mesh tab in the Fusion user interface. Under Modify, I'll access the Reduce tool. This is my primary method for reducing the complexity of the model. I usually prefer to perform the reduction in two passes. This gives me more control over the amount of detail that remains after each step. I'll start with a reduction, leaving the type set to proportion and the remesh type set to adaptive, which are both the default settings. I'll set proportion to 25% and click OK. Returning to the mesh properties, you can see that the facet count has been reduced by 75%, bringing it down to approximately 300,000 facets. That's much closer to my target of getting below 100,000. Looking at the model, I can see the facets have become larger, but the definition is still very sharp, and I'm happy with the amount of detail that's been preserved at this stage. I'll now repeat the process a second time, this time removing a further 85% while leaving all the other settings at default. I can preview before applying to check the result that I'll be getting. I'm happy with the resulting level of detail for my use case. Checking the mesh properties confirms that I'm happy with the facet count too. The model now sits nicely between the recommended 10,000 facets for modeling and the practical upper limit of around 100,000. Before converting the mesh into a solid model, there's one more thing I like to do, and that's getting the scale right. I find that STLs imported from 3D scans often come in at a scale factor of 10:1. I haven't done much research into why this happens, but it's quick enough to fix and sort out. Under the Modify panel in the Mesh tab, I'll access the Scale Mesh command. I'll perform my first scaling operation using a uniform scale ratio of 0.1, reducing the overall size of the model to 1/10 of its original size. I'll perform a second scaling operation to fine-tune it to the exact dimensions I'm after. In this case, I want an overall width of approximately 120 millimeters, and that will define the ratio for my next scaling. And there we go. I'm happy with that size. To be clear, both the reduction and scaling could have been done in a single operation. I simply prefer doing them in 2 steps, as this allows me to make small adjustments during the second pass. Now I'm ready to convert this mesh into a solid model. Under the Modify panel, I'll select Convert Mesh. Choose my mesh body, leave the remaining settings at their default. This process can sometimes take a while. If your mesh has more than 10,000 facets, you'll receive a warning that the conversion may take some time. I'm going to click OK and proceed. There we have it. Fully workable 3D model. Next, I'll make the geometric modifications using normal Fusion parametric features. Once converted, I can use all of Fusion's standard modeling tools. I can even create features that affect multiple bodies, join bodies together at the same time, or cut the body into multiple bodies. Ideally, you wouldn't want to work with a model that started with this many facets, but I thought it would be useful to choose something extremely detailed to demonstrate that almost anything can be made workable by simply reducing the facet count into the recommended range. After completing the modeling, I'm ready to export the model back to the STL format, or switch to the manufacturing environment, or shortcut the process by simply clicking the 3D print button. I hope you found this useful. Thanks for watching.